In this video, we're going to analyze the reduction in steam losses from a steam leak. We're going to go ahead and move to the energy screen. We're going to have to add two elements now. We're going to have to add a boiler to raise the steam, and then we're going to have to add the steam end use. We'll begin by adding the boiler, which is a piece of heating equipment. We'll move to boiler, and we'll need to know the fuel source or fuel type, in this case natural gas, its price, which is already baked in, and finally the most important piece of information here is then the fuel to steam efficiency. In this case, we're going to go with a number like 75%. That may seem low, but when you think about all the losses in a steam system and you're raising to higher pressure, it's not unusual to have a value at that. We're going to copy paste to proposed, and now we're ready to go and specify our steam leak and see what we can save by reducing or eliminating that leak. We're going to move to the energy end use drop down, and we're going to pick steam losses. Now there's two ways to calculate steam losses in REDScreen. One is as a plume, that is essentially that cloud above a pipe. The other way is from a leak of a known size. We're going to use a leak of a known size. I know that this leaking steam trap has a diameter of leak of about 1/8 of an inch, or 0.125 inches. And I know that my system is operating at a steam pressure of 200 pounds. I'll enter that. Once I do that, REDScreen in fact tells me the number of kilograms per hour, and it also knows the condition of the steam from the pressure. If I'm running superheated steam in the system, that is if I'm heating above the saturation temperature, I can enter that here, but I'm not, so I'm going to simply enter the 198, which is the saturation temperature REDScreen has told me. At this point, we need to know the schedule for the leak. Well, leaks don't have schedules, so that's going to be 24/7. We've now calculated 283,000 kilowatt hours of energy at the leak. Now, let's deal with the proposed case. I can copy paste to proposed, but at the end of the day, it's a very simple analysis here. I'm simply going to eliminate the leak by taking its diameter as 0. The energy use in the proposed case is 0. And what we're going to do is use the include measure screen to see what this leak was really worth. Moving to the include measure, it looks like this leak was costing us $11,000, a little more than $11,000 a year. That's pretty significant. Even if you consider a $3,000 or $4,000 intervention to eliminate a steam trap that's leaking, this thing pays back very quickly. A great use of REDScreen to identify low cost, no cost opportunities.